This is the longer version of the problem of the solution, where I use ideal op-amp conditions without using the formula, direct formula. If you want to view the shorter version of the video or the solution, you can go to the next video. So for an ideal op-amp, all you have to remember is there's no current flowing into the op-amp. The current flowing through to the inverting and non-inverting terminals are 0, and the voltage across them are the same. If you assume this node as A and this node as B for an ideal op-amp, IA would be the same as IB, that be 0. Let this be IA and this is IB. So you have current IC flowing through the capacitor and current IR flowing through the resistor. The other condition is voltage at the first node would be equal to the voltage at the second node. These two are the basic principles of an ideal op-amp. For this problem, the node B is connected to ground, so VB would be 0. Since VB is 0, VA would also be 0. Now, you know that there's no current flowing through IA. IA would be 0, so IC would be equal to IR. Since IC is equal to IR, you get this equation. You just have to calculate the what IC and IR is. So the current flowing through the capacitor is given by C dVC by dt. VC is the voltage across the capacitor, and the current flowing through the resistor would be given by VA minus V0 by 100 kilo ohm. It's VA minus V0 because current flows from node A to the output. And VC, the voltage across the capacitor, is given by VI, the input voltage, minus the first node A. Now, since we know that VA is 0, so VC would be VI, and here this equation reduces to C d VI divided by dt would be equal to minus V0 by 100 kilo ohm. You have to find V0, so V0 would be minus 100 kilo ohm multiplied by the capacitance is 0.1 microfarad, and d by dt of the input voltage VI. So simplifying this, you would get 100 kilo ohm multiplied by 0.1 microfarad, and differential of 1.25 T is 1.25. 1.25, and you would get the answer as 12 minus 12.5 millivolt. you can use this to get the equation for a differential amplifier, where C dV by dt would be equal to minus V naught by R. So V naught would be minus R C dV by dt, dVi by dt.